Welcome Math 30-2 to your fourth lesson in applications of exponential logarithmic functions. And in today's lesson, we will be dealing with solving logarithmic equations. So to start off with question 1, we have log x squared is equal to log 16x. And it wants us to solve the following logarithmic equations. Solve for x. Looking at this, they both have logs, so we're just going to put x squared is equal to 16. Continuing, x is equal to plus or minus 4. I now have to see if this is true for both cases. We're going to check. What I'm going to do is put in 4 for x. So we have log 4 squared is equal to log 16. So this one works. Let's try another one. We will put in log negative 4 squared is equal to log 16. This one works as well. So that works perfectly fine. Let's try to look at this next one here. It says we have 2 log x is equal to logarithm of 16. I'm going to simplify this by putting log x squared is equal to log 16. Well, then I have x squared is equal to 16. Square root both, I'm going to get x is equal to plus or minus 4. All right? Solving this now, we're going to check each one. I'm going to have 2 log 4 is equal to log, see if we can get that equal to log 16. Now I have log 4 to the power of 2 is equal to log 16. So this one works. So we know x can equal to 4. Let's check another one, negative 4. I'm going to have 2 log negative 4. Now right here I have a problem. I can never log a negative. Therefore, negative 4 does not work. So x cannot equal to negative 4. So my only answer is x is equal to 4. The next part here wants us to do this by graphing. So I'm going to grab my graphing calculator and plug this into each one. There we go. I'm going to clear this and plug it in. We have here this equation right there. But if I want to find the y-intercepts, I'm going to go y is equal to log x squared subtract log 16. Okay? All I did was put everything onto the x side and make it equal to 0. Because it's 0 is equal to that, so we're finding my zeros. Just put that in. We're going to have log x squared and bracket, and we're going to subtract, what is it? Log 16. Okay? That's my bracket, and I'm going to graph it. And there's my graph. If I look at it, I have 2 intersects. It goes like this, and it goes like this. Now I'll find my intersects. I'm going to, and we want to calculate my zeros. Go left, enter, go right, enter, and then my guess, down there. I get negative 4 and 0. And the other one will give me 4 and 0. So it works. Let's try graphing the second one, this equation here. I'm going to end up graphing y is equal to 2 log x minus log 16. So we have my y equals, and we're going to insert a 2 there, and we're going to delete, and that's essentially it. Now look at this graph, there's only one intersection, and that's at the 4. So this one looks like this, and my intersect is, there's x is equal to plus or minus 4. Here, x is only equal to 4. All right? Now explain why the solutions in the logarithm equations are the same but not even. Why can this be written as this, but yet they do not equal? Well, if I look at this here, we're going to compare my domains. Okay? If I look at this one here, x is squared, so it could be all positive or all negative. But it cannot equal to 0 because you cannot get 0 there. So basically my domain for y is equal to log, and we have x squared. We have x such that x cannot equal to 0, and x is an element of all real numbers. Look at my domain for my next one. Y is equal to 2 log x. Well, we can't log a negative number. In this one, here x could be negative because we square it. We have x such that x must be greater than 0. And x is an element of all real numbers. So that is kind of why that works that way, okay? Because this one here is squared. All right, let's take a look at example number 2. Solve the following equations. We have these right there. I'm going to start off. First thing I want to do is I'm going to combine these here together. I'm going to end up getting log, make this simplify by combining. So I'm going to have here log x plus 1, and the subtraction is our division rule, divided by x, 2x minus 3. Okay? I have all that there, is equal to log, and this is all in base 4, 4 to the 8. Now I look at this, this must be equal to that. It's kind of like the question we had before. So I'm going to end up getting x plus 1 all over 2x minus 3 is equal to 8. I want to solve for x here. X plus 1 is equal to 2x, subtract 3, multiplied by 8, I get x plus 1 is equal to 16x minus 24. I'm going to now solve for x. I'm going to end up getting 15x is equal to 25, so x is equal to 5 over 3. I divide both of those by 15. So that's how I solved the first one. Let's take a look at the second one here. First thing I'm going to do is put all my x's on one side. All right, so we have log 6, and I'm going to have x plus 4, and I'm going to add log base 6, log in base 6, x plus 3 is equal to 1. Now I don't like this here, I'm going to combine, but I also don't like that there, but I can look at that later. So combining this here, I'm going to end up getting log 6, I'm going to have x plus 4 all over, or multiplied by x plus 3. Now this is all equal to 1. Now there's two ways I could do this here. I know this is the same as, this one is the same as log 6 to the power base 6, so 6 to the power of 1 is equal to 6. So I could do it that way and say this is equal to this. Or I could go 6 to the power of 1 is equal to 6, so therefore this must equal to 6. And in other words, this must equal to 6, or I could say this here must equal to 6 to the power of 1, which is 6. So I could solve this now. I'm going to have x plus 4 multiplied by x plus 3 is equal to 6. All right, there's two ways of doing that and looking at it. I'm going to expand this out. I'm going to get x squared plus 7x plus 12 is equal to 6. So now I'm going to get x squared plus 7x plus 6 is equal to 0. Just subtracted 6 from both sides. I factor this out. I'm going to get x plus 6 and x plus 1. Now, looking at this, I have two answers. X could equal to negative 6 or negative 1. Now, let's see if either one of those work. I'm going to check. I put in negative 6 for x. I'm going to get log 6, negative 2. Now, remember, we can't log a negative. And same thing here. I'm going to have negative 3. So negative 6 doesn't work because we can't log a negative. So my only answer is x could equal to negative 1. And that is it. Let's take a look at my next question here. It says solve the following. Log 2 base 3, or 2 log base 3x minus log base 3, x plus 3, subtract 3 is equal to 0. And it wants it into two decimal places. So I'm going to start this off by just isolating for all my x's where possible. I'm going to have log, and I'm going to leave this here, log base 3 x squared minus log base 3 x plus 3 is equal to 3. All right? Now I'm going to combine these two equations together. So I'm going to get log 3x squared all over x plus 3 is equal to 3. But I'm going to put this into log. So 3 to the power of what is 3? Well, that's going to give me 27. So I could say log 327. Now I know that this is equal to that. Or I could have said this here, all of this is equal to 3 to the power of 3, which is 27. So I'm going to get x squared all over x plus 3 is equal to 27. So I have to cross multiply to solve for x. So I'm going to get x squared is equal to 27x, and here we're going to have to plus 81. Okay, multiply this, x plus 3, and here we have x plus 3. Okay, I'm going to end up getting 81, which gives me 0 is equal to, I'm going to move everything on this side, so I have x squared minus 27x plus 81. Now to factor this is very difficult. Look, it's going to be challenging. And knowing that it's going to be decimals, I'm going to use the quadratic formula. The quadratic formula will give me x is equal to plus, okay, or x is equal to negative b squared, or negative b, so that's 27, plus or minus the square root of b squared, so negative 27 squared, minus 4 multiplied by a, which is 1, multiplied by c, which is, in this case, that should be negative 81. Negative 81. All over 2 multiplied by a. Okay? Now if I solve this, plug that into my calculator, I'm going to end up getting x is equal to 29.72 and negative 2.72. Okay? I look at this now, I put in negative 2.72 into x, and right here, that can't work because we have x there, that's negative, this is negative, can't have negative logs, so my only answer is 29.72. Alright, now we're going to look at more complex things. So it says solve the following equation, log 2, log x, log base 2, log x, 3x plus 4 is equal to 1, by twice converting the exponential form. Okay, so we're going to convert to exponential. First of all, I know this here must all equal to 2 to the power of 1, right? Because that's what it's saying. If I put it into exponential form, we're saying 2 to the power of 1 is equal to log x 3x plus 4. All right. So we have 2 is equal to log x 3x plus 4. Now we know x to the power of 2 must equal to that. So x squared is equal to 3x plus 4. So now we've gone into exponential forms twice. First exponential form, then exponential form again. Now we're going to make that equal to 0, so I get x squared minus 3x subtract 4 is equal to 0. I'm going to factor this. I'm going to get x minus 4 and x plus 1. So my two answers are x could equal to 4 or negative 1. Let's check both of them out. The 4 will work, everything's positive. Negative 1, I can't have a base of negative 1, can I? I have a base of negative 1. So the 1 doesn't work, x could only equal to 4. Okay, that's the only one that will work. Alright, question number 5. Solve and verify. Solve and verify log x squared minus 3 log x is equal to 10 by using the laws of logarithms. I'm going to look at this here. First thing I'm going to do is put that 2 in front. So I have 2 log x minus 3 log x is equal to 10. Next thing I look at this, it says 2 log x's subtract 3 log x's gives me 10. Well, that means I'm going to be left with, I'm going to be short a log x. So I'm going to have negative log x is equal to 10. Alright? Then I want to get my x positive, so that's going to be log x is equal to negative 10. And remember, this is an imaginary 10, so 10 to the power of negative 10 is equal to x. Okay? So here we have x is equal to 1 over 10 to the 10. And that's it. And it wants us to check. We could check if we want, put this in, see if it will work. And if you plug this into this equation here, you'll end up getting 10. Okay? Let's try this one here. Explain why the equation of this cannot be solved using the laws of logs. Well, I look at this. This is because this here is not the same as log x squared. It's not the same as log x squared. This is squaring log of x. This is saying x squared, and then we log it. This one's saying all of this, and then we square it. Okay? Now, solve the equation by using the following steps. We're going to solve this using the following steps here. So it's kind of making it easier. We're going to replace log of x with a. So we're going to be left with a squared minus, we're using this equation here. We're using equation b, minus 3 log, 3a, because log x turns into a. So 3a, right? Because here's a is equal to 10. Now we're going to solve for a. So a squared minus 3a, subtract 10, is equal to 0. And I'm going to continue this. We'll have, factoring it out, a minus 5 multiplied by a plus 2 is equal to 0. Now solving this, I'm going to end up getting a is equal to 5 or negative 2. Now we want to see if there's any extraneous solutions. Well, a is equal to 5 or negative 2. And so in other words, we have log x, log x is equal to 5 or log x is equal to negative 2. And we're going to see if both of these could work. So this is x is equal to 10 to the 5. Well, here's 10. X is equal to 10 to the negative 2. So I'm going to check if these are going to work here. Now I'm going to do the extraneous solutions. So let's try this out. This is the same as 1 over 100. This is the same as 1 over, 1 over 100,000. I look at this here. I could plug both of these in. And if we plug these both into these equations, they will both work and they both check out. So these are my two answers. And if we notice, these answers here are different than the one up here. Because like we said before, this is not the same as that. So there's two different methods we have to use to solving these. Okay? So here we have another student tried this, and they made a mistake. Now let's see if we can find out their mistake. So what they did was they put this up there, and then they said a and a squared. Now, here's their first mistake. They have to move this 3 in front, because this is not saying we have x cubed here, not log x all cubed. It's just x cubed if they let it in. So basically, we have to first go log x squared minus 3 log x is equal to 0. So we end up getting a squared minus 3a is equal to 0. Now we're going to have to try and solve this for them. So we're going to end up getting a multiplied by a minus 3 is equal to 0. So let's plug this back in. We're going to get log x multiplied by log x minus 3 is equal to 0. So I get log x is equal to 0, or log x is equal to 3. So x is equal to 10 to the 3, or x is equal to 10 to the 0, which is 1. So x is equal to 1, or x is equal to whatever this is, 1,000. Okay, so we check back, see if there's any extraneous roots, and you're going to end up getting, if we check back, we have both of these could be possible answers, and they'll both work. Okay, I'm not going to do that. You could plug these into your calculator, see if they both work. So those are my two answers, and that's everything. Hopefully you understood this. Good luck. If you have any questions, don't feel free to ask me tomorrow.